Recording started.
All right, hi Bio20 students. We're going to do a recording here, and this is going to help you to prepare for our first test, which is going to be on Thursday, March the 8th. And if you watch this recording and then practice any questions on the email that I sent earlier, this is kind of a review type email. If you do those two things, that should really... Sorry guys, I should have put my phone somewhere else. I'm really sorry guys, it'll be done in a second. We'll get started. Maybe I'll just go turn down the answering machine while I'm thinking of it. Alright, sorry guys, that's the most interesting way I've started off one of these recordings, but anyways, let's go with it. So we got a cartoon here, and it's kind of showing a picture of the food chain. It shows that we, in fact, are part of the food chain ourselves. So I just thought it was kind of a cool picture. So let's get into this stuff then. We're talking about some of the differences between communities, populations, and ecosystems, some of those different terms and what they mean. So a population is the group of the same species of organism living in one area. So for example, if you have a group of lions in one area, that would be a population. And looking at a community, on the other hand, that's a group of many different species living in one area. So if you have ducks, geese, frogs, etc., all living in the same area, that's a community of organisms. Okay, now we talked about the difference between biotic and abiotic factors. Biotic, of course, the word's kind of related to biology, which is the study of living things. So biotic factors are living things. So, of course, plants, animals, bacteria, and other organisms as well. And abiotic factors, on the other hand, are non-living things. So we're talking about things like chemical and physical factors. So if you look at the picture here, we could be talking about things like rocks, water, soil, or even things like the pH of the water. That as well could be an abiotic factor. And when we look at an ecosystem, remember that's both living and non-living things interacting together in one area. Okay, so this picture, of course, is a pond ecosystem. And so let's go on to the next page. So we're going to talk about where soil comes from and what are the different types of soil. Well, we know that soil comes from plants and animals. When they've decomposed, that produces soil. And they're also soils are also a result of rocks and minerals breaking down as well. So we looked before at the difference between humus and peat. And humus is land plants that once they die and they decompose, they form humus, and peat, on the other hand, is formed from water plants that have decomposed. Okay, so when we look at soil, there's two main types of soil. There's topsoil and there's subsoil. Remember that topsoil is made of mainly organic matter, so that's once living matter, and it contains most of the nutrients of the soil. Subsoil, on the other hand, is made up of three things: gravel, sand, and clay. Okay, so here's an example of what if you bought some peat moss from the store, you might get a big bag like this, and this stuff makes great soil for gardens. Okay, now when we look at how acidic a soil is, that's going to affect the plants that can grow in it. And so, of course, alkaline soils have a high pH, and basic, another name that is for basic soils. Acidic soils are the opposite, and they have a low pH. And remember that acidity or alkalinity is just kind of all part of the same spectrum. So if we talk about alkalinity, in a way it's also a measure of acidity, right? So this is the pH scale going from 0 to 14, 7 being neutral. And of course, something like 0, pH of 0, that's a very strong acid, something like battery acid. You don't want to get that stuff in your eyes, of course. Something like hand soap has a pH of 10. Ocean water has a pH of 8. All right, we're going to look at some different factors that affect the heat distribution in the Earth. And we looked at the differences between the climates in deserts and oceans. And we saw that deserts are regions that experience more extremes in temperatures, so their days are hotter, their nights are colder. And on the other hand, if you're looking at a coastal area, they're found near large bodies of water, such as oceans, and so the temperatures are more moderated, so they're made less hot and less cold. And that's because of the large bodies of water. Large bodies of water take a long time to heat up and to cool down, so they're known as heat sinks. And so this is a picture of Vancouver, a very beautiful city, and it's got a warmer climate in the winter because of water's ability to hold heat. Okay, you might remember this term, the albedo effect. What that represents is how much energy from the sun is reflected back up to the sky. And so most of the albedo effect comes from snow. So because snow is very reflective, 85 to 90% of the energy from the sun is reflected back up. Whereas if you look at this situation where we don't have snow, 70% of the energy from the sun is absorbed. Now let's look at a quick refresher on how the greenhouse effect is believed by some to work. Again, we looked at the fact that there are differences of opinion as to whether the greenhouse effect is occurring to the extent that some people believe it is. But overall, the way the idea works is just like with a greenhouse, it traps heat within the greenhouse. So it's believed by some that greenhouse gases trap heat within our atmosphere. So with a greenhouse, the light waves from the sun are able to pass through the greenhouse. But once those short light waves strike objects within the greenhouse, they're changed into heat waves, which are longer, and the longer heat waves are not able to pass back out of the greenhouse. So as a result, heat builds up, and it gets really hot in there, which is perfect for growing vegetables, right? Okay, the greenhouse effect, similar idea. So light waves from the sun are able to pass through the layer of greenhouse gases. Now, what are these greenhouse gases? Mainly carbon dioxide. Okay, so just like the glass of a greenhouse, we have this layer of greenhouse gases. So the gases are able to pass through, but once they strike the Earth and become longer heat waves, again, they're not able to leave our atmosphere, so they become trapped within our atmosphere. And over time, it's believed by some that the greenhouse effect can lead to global warming. Global warming is basically an overall increase in temperatures across the Earth. So again, the main gas that's believed to be responsible for that is carbon dioxide gas. I'm sure you guys would say that on a cold winter day, the idea of the greenhouse effect might not be such a bad idea in Alberta. Okay, just kidding, right? So remember that the greenhouse effect is something different from the ozone effect. The greenhouse effect, again, relates to carbon dioxide gases and heat trapped within our atmosphere. The ozone layer is a concern because it is thinning and it may be disappearing in some areas. Now, why is that important? Well, the ozone layer protects us from harmful UV radiation, which can lead to skin cancer. So if the layer is thinning, then you're going to have more UV radiation and skin cancer as a result. Remember, what's believed to cause the thinning of the ozone layer is an excess of aerosol sprays. Okay, so they have these chemicals called CFCs, and that's what's believed to cause the thinning of the ozone layer. We often also call the thinning of the ozone layer an ozone hole. So here's a little cute cartoon that kind of shows an ozone hole in the Earth's atmosphere. Excuse me, guys, just going to get a little drink, have a cold here. All right. So where does ozone come from in the beginning anyways? Well, oxygen floating around in our atmosphere is bombarded by UV rays, and that causes ozone to be produced in the beginning. You might be interested to know that sometimes in hotels, they use ozone to get rid of the cigarette smell that's in the rooms. So they produce ozone and it actually gets rid of that smell. All right, so when we're talking about all this stuff like the greenhouse effect, thinning of the ozone layer, sometimes we say, hey, there's a lot of stuff going on, and sometimes it causes people to be a little bit concerned about what's happening to our Earth. But remember that what happens on the Earth and in the universe is under God's control. And remember that if we know God through His Son Jesus, we don't have to fear what's going to happen to our Earth or to our lives. I like this verse from Psalm 91:1. He who dwells in the shelter of the Most High will rest in the shadow of the Almighty. And this is a good picture that goes with that. Okay, so back to talking about sunlight again. Sunlight can cause different types of harmful radiation. And this radiation can damage the DNA of our cells. It can cause them to mutate. And again, that can lead to cancer. We already talked about the fact that the ozone layer does absorb most UV radiation. We're going to look at some of the other layers of the atmosphere. There's also the ionosphere. It absorbs X-rays and gamma rays. And the magnetosphere absorbs charged particles, which can also be dangerous. So it's good to know what each one of those layers, which types of harmful particles are absorbed by them. Okay, so here's the different layers of our atmosphere. Remember, our atmosphere is just the air that encircles the Earth. And remember that the troposphere is the lowest layer, the ionosphere is the highest layer. Okay, let's kind of shift gears a bit and look at the different layers of a lake. Well, the shallow part of a lake is called the littoral zone, and the bottom of a lake is called the benthic zone, or the benthos. And we also talked about how a lake can become filled in with organic matter over time, and this process is known as eutrophication. When we looked at bodies of water, we also looked at rivers, and we saw that the location where a river enters an ocean is called an estuary. Let's see a picture of that on the next page. So here's an estuary, a place where a river enters an ocean. Okay, so let's look a little bit here at the process of photosynthesis. Amazing process that captures energy from the sun. You can see from these different diagrams what is coming into the plant and what is leaving the plant. Overall, of course, photosynthesis helps green plants make food. And we can see the equation for it here. So we see which substances are used up, and they are known as reactants. So carbon dioxide and water are used up, and they're used to produce sugar or glucose and oxygen. So those are the two most important products that are produced. And you can see that the C, carbon on this side of the equation, is used to produce sugar on this side. And you can see how the H's are used to produce sugar as well. The oxygens come from both and produce oxygen. Rather, the O's, I guess you could say, are used to produce O2, oxygen. All right. I thought this was kind of neat. This was a picture of an electric vehicle that someone produced that actually kind of relates to photosynthesis. So hey, what will they think of next, eh? All right. Now, do you remember the differences between a pond and a lake? Well, it has to do with the amount of penetration of sunlight. So with a pond, light is able to reach all of the lake, the bottom of the lake. Whereas with a lake, the sunlight can only reach part of it, but not the bottom, or not the deepest part of the lake. So we've talked about some of these zones before. We've talked about the littoral zone. It's the most shallow zone. There's also the limnetic zone, which is the open water of the lake, where most of the photosynthesis is taking place by the plankton. And the profundal zone is deep water, and there's no photosynthesis here, and because of that, organisms need to depend on matter sinking down to the bottom to get food. right, so whenever we're talking about lakes and rivers, we're talking about freshwater communities, whereas marine communities are talking about places where salt water is found. And they're basically talking about oceans or seas. So you can see here a diagram of a marine community, and plankton are the main producers. Now, it's important to note that plankton can be photosynthetic or they may not be photosynthetic. Now, plankton are often eaten was what I meant to say. Plankton are eaten, phytoplankton I should say, when they're in water. Phytoplankton are eaten by zooplankton, which are then eaten by fish and other creatures, later eaten by seals and polar bears. All right, now here's an interesting fact. Did you know that an estimated 50 to 80% of all life on Earth is found under the ocean surface? And the oceans contain 99% of the living space of the planet? I thought that was pretty cool when I came across that. Okay, you guys remember this word succession? Well, what does that mean again? Succession describes all the changes that take place in a community between when it first started out, in other words, plants start colonizing the area, to when it reaches its final stage known as the climax community. Now, as you can see, based on the different times that are given here, the climax stage is the most stable and lasts the longest. Okay, well, we talked about different nutrient cycles or element cycles, and for instance, we talked about the carbon cycle, nitrogen cycle, phosphorus cycle. This is showing us the carbon cycle, and of course we talked about how carbon dioxide is important. It's produced by cellular respiration by plants and animals. Of course, that's when they burn sugar to get the energy from it. And so it goes into our atmosphere. Now, some of that carbon dioxide in our atmosphere later goes into our oceans. It combines with water in the oceans and produces carbon or carbonic acid. All right, the last thing we're going to talk about, guys, is the difference between warm-blooded and cold-blooded creatures. Okay, so here's a little diagram showing a warm-blooded creature like a bear. There's a cold-blooded creature like a lizard. All right, so warm-blooded, another word for that is homeothermic. These creatures can regulate their own body temperatures, so they can live in a larger range of areas because they have the ability to keep their body temperatures the same no matter what the outside temperature is. Cold-blooded or poikilothermic creatures, such as lizards, cannot regulate their body temperature. So instead, they're dependent on the environment to provide them with enough warmth. Now, if you think about what the word homo means, homogenized milk, it's the same throughout. You don't have different layers of the milk. So that kind of helps us to remember that warm-blooded creatures, they're the same throughout. In other words, their temperatures are the same no matter what the environment is. All right. Great, guys. We've come to the end of this recording, and I'd just like to encourage you to, after you watch this recording, go over the list of concepts that I put on an email and just kind of check them all to make sure you understand all these concepts. You might need to go over this recording again, possibly. Also, you can go over the PDF file as well that I send with the recording. So please study hard for the test on Thursday next week, March the 8th. I hope you guys have a great weekend. Take care. God bless. Bye for now.